My name is Compton James Tucker, and I am a scientist at the Goddard Space Flight Center. We're very interested to improve our knowledge of the carbon cycle globally. Where is carbon going in vegetation, and how long does it persist? In the study, we used a large volume of commercial satellite data, hundreds of thousands of commercial satellite images at the 50 centimeter scale to map trees, to identify trees in a semi-arid region from the Atlantic Ocean to the Red Sea in Africa. What we actually mapped were tree crowns. We then used our tree crown data to make predictions from the allometry, which was also collected in the same region. And the data are very important. The processing code is important. The training data is important. The allometry is important. And then understanding the results that come out of those four components in the study. This study has been in the works since 2015 or 2016. I started 5 or 6 years ago draining the archive of all of the data from Africa. This has taken me 3 or 4 years to get all the data. Secondly, Kit, who's one of our team members, as a graduate student in computer science, he wrote our processing code. And it's highly optimized neural net code. It works very well. He worked on that for 2 or 3 years. Then you need the training data to go with the processing code. When you use machine learning or artificial intelligence, you need to train on something so you have confidence that that's what you're measuring. The training data is where you go out and you select all different types of trees. And they have to have a green tree crown and an associated shadow to be a tree. And Martin Brandt did this over 3 or 4 months and selected 89,000 or 90,000 individual trees. It's a heroic effort. Now there are people like Pierre Arnaud, one of our co-authors, who go out and they sample trees and they measure the tree crown. They then cut the tree down. They then measure the volume of leaves in the tree crown. The same for the wood and the same for the roots. And so we then convert the tree crown data, which we measure, into the predicted leaf mass, or carbon, the root carbon, and the wood carbon of every individual tree.
You know, individual tree crown is probably the highest resolution you're gonna get, and like knowing the exact number of trees and also when they have leaves throughout the year is going to be really, really important for improving our climate models.
Then you put all this together and you run it on a supercomputer. So we would run the data this way, run it that way. Then you take the results. That's really the fun part, seeing what you did, how well you did it, and what it can be used for.
So the viewer is an important tool for NGOs that are interested in understanding if their tree restoration programs have paid off. But it can also be used for the local farmer who would be interested in knowing how many trees are standing on the fields and are they alive, are they dead, etc.
And with the viewer, you can zoom into individual trees and see how much carbon is there in the leaves and the wood and the roots, and the specific location of that tree. Or you can aggregate the data up to an area of 100 meters by 100 meters or 1 hectare. We plan to expand our work next to Australia, and then maybe to Eastern Africa, Southern Africa, Central Asia, and possibly other arid and semi-arid areas.